Welcome to Everyday Mathematics. Today we're still on the MIT Integration B qualifying exam 2010. Problem 16, 17, 18, 19, and 20 are going to be our problems of focus. So problem 16 is the definite integral from x equals to 0 to x equals to 1 of 1 over x to the power 4 minus 13x squared plus 36. Problem 17 is the indefinite integral of natural logarithm of x over x. Problem 18, which is a problem of 1 plus cotangent x over 1 minus cotangent x. Problem 19, which is also an indefinite integral of cosine x plus x times sine cosine x all over x times bracket x plus cosine x. And problem 20, which is the definite integral from x equals to 0 to x equals to pi over 2 of 1 over sine x plus secant x. So I hope you do stick around and you enjoy following as we try to solve each problem at a time. To problem 16, which is the definite integral from x equals to 0 to x equals to 1 of 1 over x to the power 4 minus 13x squared plus 36. So this is the same as definitely 0 to 1 over, let's factorize that, x to the power 4, and we have 9x squared minus 4x squared plus 36, this over dx. And this means that we have 0 to 1 over x squared out, x squared minus 9 minus 4 x squared minus 9 dx, which is the same as 0 to 1 of 1 over x squared minus 4 x squared minus 9, which is the same as 0 to 1 of x minus 2 x plus 2 x minus 3 x plus 3. So we can create a partial fraction out of this integrand here and then solve everything or every item at a time. So our integral, as we said, is from x equals to 0 to 1 of 1 over x minus 2 x plus 2 x minus 3 x plus 3. And so we can create a partial fraction by saying that x minus 2 x plus 2 x minus 3 x plus 3 is the same as a x minus 2 plus b x plus 2 plus c x minus 3 plus d x plus 3. And so we can solve this one at a time by multiplying this respective denominator at a time. So let's say, for example, if we multiply this on both sides and then setting x be equal to 2, that means for a, we can, this other parts will go to 0, and this part here will have to focus on what, because let me just go ahead and multiply this by x over 2. This is the same as x plus 2, x minus 2, this and that will cancel, x minus 3, x plus 3 is equals to a x minus 2 times x minus 2, this will cancel, plus b x minus 2 x plus 2 plus c x plus 2 x minus 3 plus d x plus 3 times x minus 2. So when x equals to 2, that means that we have 1 over, this becomes 4 this becomes -1, and this becomes 5 equals to a, and the rest becomes 0. So that means a is equals to -1/20. Okay. Since we've gotten a and we have x minus 2, x plus 2, x minus 3, x plus 3 is equals to -1/20 x minus 2 plus b x plus 2 plus c x minus 3 plus d x plus 3. So for b, we'll just have to multiply by x plus 2. And so what that means is when x equals to -2, we have 1 over -4, -5, +1 is equals to b. That means that b is equals to 1/20. And then for c, we'll have to substitute with x equals to 3. So we have 1 over 1, 5, because this is going to cancel away, so we're left with this. X equals to 3, this is going to be 6. Right? So it's equals to c. That means that c equals to 1/30. And then for d, we multiply both sides by x equals to -3. So we have -5 there, -1, and then -6 equals to d, which means that d is equals to -1/30. Okay, so this is a, and so our integral becomes very interesting. So our fraction 1 over x minus 2, x plus 2, x minus 3, x plus 3 is now equal to -1/20 times 1x minus 2 plus 1/20 times 1/x plus 2 plus 1/30 times 1/x minus 3 minus 1/30 x plus 3, such that our integral from x equals to 0 to x equals to 1 of x minus 2, 1/x minus 2 times x plus 2 times x minus 3 times x plus 3 is equals to the integral from 0 to 1 of -1/20 1/x minus 2 plus 1/20 1/x plus 2 plus 1/30 times 1/x minus 3 minus 1/30 1/x plus 3 dx. So it's very important to see within the domain 0 to 1, definitely this is 1 over something less than 2, so this becomes negative and negative here. So the integral within that domain becomes 0 to 1 of 1/20 1/2 minus x. Yes. And then plus 1 over 20 x plus 2, and then here again we will now flip 1 over 30 1 over x 3 minus x minus 1 over 30 1 over x plus 3 dx. So this now becomes 1 over 20 natural logarithm, negative definitely, of 2 minus x, right? Plus 1 over 20 natural logarithm of x plus 2 minus minus becomes plus 1 over 30 natural logarithm of 3 minus x minus 1 over 30 natural logarithm of x plus 3 from 0 to 1. So which becomes, when x equals to 1, this becomes negative 1 over 20 log 1, that tends to 0, plus 1 over 20 log, this is 3, 1 plus 2, plus 1 over 30 log 3 minus 1 is log 2, minus 1 over 20, 1 over 30 log 4 minus negative 1 over 20 log 2 plus 1 over 20 log 2, so this and that cancel, and then plus 1 over 30 log 3 minus 1 over 30 log 3, so these again cancel. So on the lower side everything cancels, and then what we're left with is this part, 1 over 20 log 3 plus 1 over 30 log 2 minus 1 over 30 log 4. So let's simplify that. We now say that our integral is 1 over 20 times log 3 plus 1 over 30 log 2 minus 1 over 30 log 4, which is equals to 1 over 20 log 3 minus 1 over 30 log 4 over 2 is 1 over 20 log 3 minus 1 over 30 log 2, right? And then what can we do? I think we can leave it at this point. That is kind of simplified enough. So problem 17, which is the indefinite integral of natural logarithm of x over x. The first thing we could say is let u be equal to natural logarithm of x. And that means that du dx equals to 1 over x. And so what that implies is we can substitute with du dx over x, which is this part here, right? So therefore natural logarithm of x over x can be expressed as log u du, which is the same as we're going to use integration by parts, du times log u. And so using integration by parts, where if you have the integral of dvu, this equals to uv minus u v du, sorry. And so since v can be considered to be the small u here, that means that we have u log u, since u is considered to be this log v, log u, minus v is simply u, du is going to be 1 over u, the derivative of log u, and that cancels out. So we have u log u minus the integral of 1, because the u's have cancelled. This is minus u plus the integration constant. Now we have to express it back to the x domain. So we said our integral is the same as u, natural logarithm of u, plus, minus u. Let's use our eraser here to remove that, and then back to our pen. So u plus c, and since we said that u equals to log of x, that means that integral log of natural logarithm of x all over x dx is the same as where u appears, we substitute with natural logarithm of x, so we have natural logarithm of x times log log x minus log x plus the integration constant. So that is our answer. So number 18, which is the indefinite integral of 1 over cotangent x over 1 minus cotangent x. What I can express this to be is, so we have 1 cotangent is cosine of x over sine of x over 1 minus cosine x over sine x, which is the same as multiply sine with sine x both the numerator and denominator, we get sine x plus cosine x over sine x minus cosine x, right? And so since this is the same as so we're having the derivative, the integral of the derivative with respect to x of sine x minus cosine x. Since this is the same as, when you differentiate sine x minus cosine x, we have cosine x minus minus sine x, which is cosine x plus sine x, which is what we have in the numerator there, over sine x minus cosine x. Now what we're seeing here explicitly is that we have, since we have, if you have the derivative of a function of fx over fx, this is the same as natural logarithm of fx, and that's our fx happens to be sine x minus cosine x. So in other words, our integral is becomes natural logarithm of sine x minus cosine x plus the integration constant, and this is what is required of us. 19, which is the integral or indefinite integral of cosine x plus x times sine x over x plus x times x plus cosine x. So my interest here would be in trying to figure out how I can separate the integrand. So cosine x plus x sine x. Using partial fraction, I think is equivalent to a over x plus b over x plus cosine, such that cosine of x plus x sine x is equals to ax plus a cosine of x plus b of x. So which is equals to a plus b of x plus a cosine x. And as we can see, a equals to 1. And then right here, a plus b equals to sine x, which means that b is equals to sine x minus 1. So that's this simple way of splitting that. So the integral of cosine x plus x sine x over x plus cosine x is the same as the integral from 1 over x plus the integral of sine x over x plus cosine x, which is the same as the natural logarithm of x plus, as we see here, the numerator is the negative, sine x minus 1 here. The numerator is the negative derivative of the denominator, so which is equals minus natural logarithm of x plus cosine x plus the integration constant, which we can duly represent as natural logarithm of x over x plus cosine of x plus c, and that is the answer that was expected of us. So, and now we are jumping on to problem number 20, which is the definite integral from x equals to 0 to x equals to pi over 2 over 1 over sine x plus secant of x. So, one notable thing we could do here is keeping the limits as they are, and we have sine x plus 1 over cosine x, and multiplying both the numerator and denominator with cosine x, so we get 0 pi over 2 cosine of x over cosine of x sine of x plus 1. Now this is a very important integral. We can call this I. If we say let x be equal to pi over 2 minus y, what this means is dx can be substituted with negative dy. And then the limits, what happens to the limits? So I becomes, when x equals to 0, because we can pull y here, and so y is equals to pi over 2 minus x. So when x equals to 0, this becomes negative pi over 2. When x equals pi over 2, this becomes 0. And then we have cosine of pi over 2 minus y. And then we have cosine of pi over 2 minus y sine pi over 2 minus y plus 1 negative dy. So the negative here allows us to flip things around, so which is 0 over pi over 2. This cosine pi over 2 is the same as sine of y. This is also sine of y. This is cosine of y plus 1 dy. So what we see here that I is the same as this guy, except that the numerator is sine. So what I is the same as the integral from 0 to pi over 2 of cosine of x over cosine of x sine x plus 1, which is also equal to the same integral from x equals to 0 to x equals pi over 2 of sine x over cosine x sine x plus 1. So in other words, 2I is equals to the same integral from x equals to 0 to x equals pi over 2 of cosine x plus sine x over cosine x sine x plus 1. So the numerator there is the same as 0 pi over 2 the same as the derivative of sine x minus cosine x, right? Over, since sine x minus cosine x squared is equals to sine squared x plus cosine x squared minus 2 sine x cosine x. This part goes to 1. What that means is sine x cosine x is the same as is equals to 1 minus sine x minus cosine x squared all over 2. So what we're going to do here is we're going to say, okay, cosine x sine x is the same as sine x, 1 minus sine x in bracket minus cosine x squared all over 2 plus 1. Okay, and there's a reason we're going to do that. So let's continue. So our integral 2I is equals to the integral from 0 to pi over 2 of the derivative of sine x minus cosine x over 1 minus sine x minus cosine x squared all over 2 plus 1. So if we say let y be equals to sine x minus sine x and cosine x, dy is equal to the derivative of sine x minus cosine x dx. So this part here can be substituted for dy. Now at the limits, for 0 we have sine 0 minus cosine 0, that is 0 minus 1, which is negative 1. So 2I equals to, at 0 we have negative 1, at 1 we have 1, positive 1, and then we have here dy. At the bottom we have 1 minus y squared over 2 plus 1, which is equals to negative 1 dy of 1 over 2, so this is 3 over 2 minus y squared, which is the same as the integral from negative 1 to positive 1 of 1 over root 3 over 2 minus y 3 over 2 plus y dy. Let's express that as partial fractions. Say our 2I is equals to the same as integral from y is equals -1 to +1 of 1 over root 3 over 2 minus y square root of root 3 over 2 plus y. This is the same as let's see, 1 over root 3 over 2 minus y minus 1 plus 1 over root 3 over 2 plus y. So that when you multiply this becomes root 3 over 2 plus y plus root 3 over 2 minus y, and the y's cancel. So we have 2 times that. So in order to cancel that, we have to multiply by 2 square root of 2 over 3 to get the same thing. So we have 2 times square root of 2 over 3 natural logarithm of square root of 3 over 2 minus y -1 +1 plus 2 over 3 natural logarithm of root 3 over 2 plus y -1 +1, and so which is the same as pulling out log -1 plus log root 3 over 2 plus 1 minus log over 2 plus 1 minus okay, so this is a negative here. We had forgotten to include that because we have this negative here, so that this becomes a negative. So negative on the upper side, we're looking at that for these two. Then we're looking for this so this becomes positive, this is negative, and then this becomes negative 3 over 2 minus 1. So these are all negatives, so what this becomes is 2 root 3 log of, actually times 2 because we have twice of each, so this becomes 4. We have square root of root 3 over 2 plus 1 all over square root of 3 over 2 minus 1, and this is the answer. Okay, so that's how you'd solve that problem, but since that is I, I'm sorry, we might have to continue. So we said our 2I is equals to 4 2 root 3 natural logarithm of square root of 3 over 2 plus 1 over square root of 3 over 2 minus 1. And so I is equals to, divide both sides by 2 is 2. Natural logarithm of root 3 over 2 plus 1 over square root of root 3 minus 1. And that's the answer. I hope that was clear. So thank you so much. Until next time, bye bye.